Hi students, problem number 14. In an oscillating LC circuit, the maximum charge on the capacitor is capital Q. The charge on the capacitor, when the energy is stored equally between the electric and the magnetic fields, has to be determined. Now, we have studied this in the theory. Suppose if this is a capacitor which is connected across a coil of inductance L. So C is the capacitor. Now the charges stored in the capacitor plates, if it is maximum. So if Q, the charge is equal to the Q maximum, then the current in the inductor will be equal to 0. Is it not? So the total energy is stored in the capacitor as electric field, and the magnetic energy stored in the inductor will be 0. So by law of conservation of energy, always the total energy will be constant. So at some instance, that is when the charge in the capacitor is maximum, the current in the inductor will be 0. When the current in the inductor is maximum, there will be no charge in the capacitor because it has already discharged. So in between, at one stage, what is going to happen? The energy will be equally shared by the electric field as well as the magnetic field. That only we have to find out. So now in total, the energy U total is equal to electrical energy stored in the capacitor plus magnetic energy stored in the inductor. Okay, now initially in this situation, no, so this is Q square by 2C. This is Q square divided by 2C plus half Li square. So the charge is maximum, current is 0. So this term gets cancelled, is it not? Therefore, what is U total is now equal to Q square divided by 2C. So the maximum charge in the capacitor is expressed as capital Q. Therefore, this will be the total energy and this will be always constant. Now, when both are shared equally, that is UE is equal to UB, that is Q square by 2C is equal to half Li square. This equation I have written small q because the quantity of charge will be different at different instants. Is it not? Q is the instantaneous charge stored in the capacitor. Only at the initial stage when it is maximum, that is Q is equal to Q maximum, that is once again equal to Q, then the current will be 0. After some time when the capacitor discharges, some charges will flow in the circuit and produce a current. So slowly the current will increase from 0 up to a maximum. Only when it is attaining a maximum value of the current, the total charge will become 0. Is it not? So it is like oscillation only, no? Electric field and the magnetic field oscillations will take place. At one stage, energy will be equally stored in the capacitor as well as the inductor. At that stage, so Q square by 2C must be equal to half Li square. Therefore, Q total, okay, Q total is equal to this Q square by 2C plus half Li square. So instead of Q total is always a constant. I told you, is it not? Total energy will be always constant. Only the electrical energy and magnetic energy will be oscillating. Is it not? So instead of total energy, left hand side, I am going to substitute Q square divided by 2C. And this is now equal to Q square divided by 2C plus, here some current will flow in the coil, is it not? Corresponding to the charge Q, some current will flow in the coil. So we have written Q square by 2C is also equal to half Li square. So instead of this half Li square in this term, I am going to substitute Q square by 2C itself because both are equal, 50-50%. So this is Q square divided by 2C. So the denominator 2c is common on both sides. So let us cancel this. So that q square plus q square is equal to capital Q square. So I will write here q square plus q square is equal to capital Q square. So 2q square is equal to capital Q square, and q square is equal to capital Q square by 2. Therefore q is equal to q divided by square root of 2. Okay, capital Q divided by square root of 2. This is the answer. So when the energy is stored equally between the electric and magnetic fields, then the charge on the capacitor is found to be capital Q divided by root 2. Understand? So which of the options? C. The option C is Q by root 2. Therefore option C is the correct answer. Understand? So in this type of problems, you have to understand the situation given. Understand? So what is the situation is given? When the energy in the capacitor is equal to the energy in the inductor. Okay? So by equating the energies, we have got the answer. Q is equal to capital Q by root 2, where capital Q is the maximum quantity of charge in the capacitor plates. I hope you must have understood well. Fine.